Welcome to my ninth lecture series on digital signal processing. So today, here I introduce multiplication of two DFT under long distance filtering sequence. Two types of method we are actually implemented coming next lecture. First one we call overlap shape method, another is overlap add method. Now the question we get that find the linear convolution using overlap shape method of the following sequences, where we are considering two sequences, one xn, another we here consider as hn, or sometimes we call hn as impulse response. So now xn is basically the long distance sequences. Here we consider 1, 2, minus 1, 2, 3, minus 2, minus 3, 1, 1, 1, 2, minus 1, and as hn is 1, 2, 3. So overlap shape method is a part of DFT. Now in overlap shape I am going to discuss about the steps that you have to follow to find out the final sequence. Here we consider some terminology like L, M, N. Now for the whole DFT you have seen endpoint DFT. So basically we see it's either 4 point or it's basically either 8 point, or maybe we are consider 16 point DFT and continue. So basically it is a power of 2 to the power n. So considering n value, then we can write n equals to 4 in term of 2 to the power n, 4, 8, 16, so on. Now here we have assumed that n is 4 for reducing down the complexity of whole calculation. So finally we can write down that n equals to 4. Now this n is the length of block we consider for long distance signal sequence. We are going to break or split it down into a n number of sequences. For calculation purpose, each block will consist of L and m minus 1 number of elements. So for overlap shape and overlap add method, we can write also one block we consider as m minus 1 and another block we consider as L. Now here we consider m as a smallest input, as we already mentioned, that is hn, or we call this is impulse response of the filter, means m here consider as 3. Now we are moving forward to terminology L. For L is basically splitting the long input signal sequence for calculation purpose. So here we are considering some formula. Now the formula we consider n equals to L plus m minus 1. As per our problem statement, we assume n equals to 4 and we know m equals to 3. So now we apply the above formula and finally we get L equals to 2. After putting the value of n and m, we finally get the value that is L equals to 2. Now for overlap shape method, if we consider overlap shape method, algo says the total input sequence as xn, if we consider as capital LS, then we broke the things. So here we mention that xn, the sequence in detail in the below of the slide, and we just break in that way L1, L2, L3, L4, L5, so on. So first block we consider as m minus 1 zeros x1n. x1n is depend on again length of the input data sequence L1. Now here we mention data from the previous sequence considered as m minus 1, and x1n is the data from the current sequence. So obviously from the, if we consider the first, we are making first the sequence, that sequence don't have the previous value, so that's why we are considering n minus 1 number of 0 we are consider. So basis on that, here from xn, the main sequence to x1n, we consider first 0 0, then 1 comma 2. 1 comma 2 are from the current sequence from the data set, and 0 0 is the m minus 1 number of 0 we are considering. Similar way for the next sequence, we are considering data from the previous sequence, and x2 is the current sequence. Basis on that, we have already the previous sequences 1 2, so that's why we written x2n 1 2, then we write down minus 1 2 for the present part is written over here. So similarly we make the other sequences also. Now let's see for our total split input data sequence of xn. We are considering in this way that x1n 0 0 1 2, x2n 1 2 minus 1 2, x3n minus 1 2 3 minus 2, x4n 3 minus 2 minus 3 minus 1, x5n minus 3 minus 1 1 1, x6n 1 1 2 minus 1, x7n 2 minus 1, and obviously in the last sequence again we don't have any value, but we are considering the total length of this split sequence is 4, so that's why we are considering again here the 0 0 as 0 padding input. So now we are applying circular convolution of hn and block of xn. So split sequence, basically split sequence versus hn. So sequences are, we get yn sequence as y1 y2 y3 as so on up to y7. So that means y1 equals to x1 in convolution of HA. Similarly, we can write down up to y2 x2n convolution with the Hn up to y7 equals to x7n convolution of Hn. Now apply circular convolution of the each split xn sequence versus hn sequence. We finally get, for particular one example, if we consider that y1 n equals to x1 n circular convolution with the hn. So y1 n we already know the convolution of x1n and hn. So here we apply the circular convolution method we already discussed in previously, that is matrix multiplication method. So basis on that, here we make the matrix, and after matrix multiplication we get the value, that is 7614. So similar way to find out the others circular convolution part, and we finally get that for y2n, that is 2 10 6 6, y3n 4 minus 6 4 10, y4n minus 8 1 2 13, y5n 2 minus 4 minus 10 0, y6n 5 0 7 6, and y7n is 2 2 4 minus 3. Now using the overlap safe method algo, we try to find out final sequence, that is yn. So we have to discard the initial two sample from each of those output block. That means my final output I will get by discarding the initial two sample of each and every output block, that is y1 n. So m minus 1 power I am going to discard. So here in first sequence, if we consider these are the total sequence, if we consider the first sequence, I will discarding 7 and 6, and I will write 1 and 4 only. Similarly, from the second block, again we discard 2 and 10. I will write down only 6 and 6. Similarly, from the third block we discard 4 minus 6, and we can write down 4 and 10, and final block if we consider, that is we are again discard 2 2, and we are considering 4 minus 3. So basis on that we get our final data sequences, that is 1 4 6 6 4 10 2 13 minus 10 0 7 6 4 minus 3. Thank you. Welcome to my lecture series on digital signal processing. So here we are basically discuss multiplication of two DFT for long duration filtering sequences, and method here we introduce, that is overlap add method. This is a part of lecture number 12. So lecture number 11 we are discussing about the overlap save method. Here we are introducing overlap add method. Now basis on the problem we are here consider the find the linear convolution using overlap add method of the following sequence, whether xn 1 2 minus 1 2 3 minus 2 minus 3 minus 1 1 1 2 minus 1, and the impulse sequence, that is hn, we are considering as 1 2 3. So what are the difference between the previous and this problem? Here we are just consider minus sign in the 1 position of the xn sequence. So almost we are considering the both the sequences the same. So now in overlap add method is a part of the DFT. Is in overlap add I am going to discuss about the detailing of the steps whatever we are follow to find out the final sequences. So here basically we are already discuss about the terminology like L, M and N individually in the previous lecture video. Now if we again little bit we have discussed about this term, that is N. Now for the whole DFT we have seen that N point DFT we are actually finding, or we have working with this N point DFT. And you are already familiar with the twiddle factor value also. This is starting from either 0, starting from not a 0, starting from in 2 to the power n term, that is 4, or maybe is considered as 8, or maybe is considered as a 16 point DFT. So basically it is a power of 2 to the power n, and considering n value, that we can write down that n equals to 4, 8, 16, so on. So now for this particular problem, if we solve, here we consider, here we are assuming that n equals to 4 for reducing the complexity of the whole calculation. Now we just directly come with the formula where we are considering. Before that I am just telling you. So previously you remember, if we consider the each block, because here we consider n equals to 4, that means we are considering the each block for the calculation. So previously we say that this is m1 minus 1 and L. So if we consider this both block, then the length considered as the n. So here we consider the first block considered as L and second block m minus 1, isn't it? So now you already know n is basically the length of the impulse response, that is hn length. We are considering as a 3, and we are already assuming n equals to 4, and finally we find out, and similar way to previous overlap save method, that is L equals to 2. Now what about the algo? We have say that I already discussed this part. If we consider the total length is n, so inside the n we are considering two separate blocks, that is L and m minus 1. So L is basically number of split data considered from the long distance signal sequence, that is xkn. So that means the length of this L is basically 2 and M1 is considered as the apparent padding 0. So you remember in the previous case, when we are considering the overlap shape method, that time we are considering the m-1 number of previous sequence and L is the current sequence we are considering. In case of the first sequence, we are considering that m-1 there is no previous sequence, that's why we are considering the 0. But in the overlap add method, we are always considering m-1 number of zeros and L is the current xk sequence. It's a part of the xn sequence. Here we write down that the total sequence xn, if we consider, then we are splitting sequence considered as a L1, L2 as like that way. Here we are considering just a L splitting by the L, and x1n we are taken as a 2 sequence and m-1 number of zeros we are considering. So our main sequence, if we consider as a 1 2 as our problem 1 2, that means the first x1n considered as 1 2 and then the next 2 sequence considered as zeros. Similarly, if we consider the second sequence, same thing here we follow, -1 2 consider as the x2n sequence and m-1 number of 0 we are considering. So similar way to write down up to total number of sequences are present is the 12. That means we are subdivided by the 2 because L considered as a 2 and then total sequence we have 6. So x1 into x6n. So let us see the total split input sequence xkn consider as, I already mentioned that s1n, that is 1 2 0 0 x2n, -1 2 0 0 x3n, 3 -2 0 0 x4n, -3 -1 0 0 x5n, 1 1 0 0 and x6n, that is 2 -1 0 0. Now same process here we also follow as overlap shape method. What we are doing, that is circular convolution. So perform circular convolution of hn and block of xkn, that is y1n considered as a x1n circular convolution of hn. So similarly here we write down up to y6n x6n convolution with the hn. So now we perform the circular convolution method we are follow. So you know the several method are there, that is DFT, IDFT method. You can implement it. You can implement it concentric circle method, but here we are implemented because of the complexity. We less down the complexity. So here we are considering, here we are implemented the matrix multiplication method. So basis on the circular convolution, here we are just first write down this part and then we write down the 2 matrix and then we multiply and finally we get the value that 1476. Similar way to other part, if we consider y2n, we are getting the value using then again using the circular convolution, using the matrix multiplication method, we get the value that -1016 y3n 3456 -6 4 y4n, that is -3 -7 -11 -3 y5n, that is 1353 y6n 2343. 4 minus 3. So after that, now we are applying overlap at method. The algo, what they say, that first two sequence of the output we are considering. For the first, that is, if we considering this is y1n and y1n having a two separate part, one we are considering y1n, one another part is m minus 1, that is means the 2. The total length is 4, 2 and 2. So first 2 considered as the output and second 2 will be added with the second sequence. First 2 sequence we are added, isn't it? So now we just directly go for the sequences. So first sequence we are considering 1, 2, 1, 4, 7, 6. For 1, 4 we are considering directly the final output data sequence, part of this final output data sequence. And what about the 7, 6? Now we are considering the second sequence, that is minus 1, 0, 1 and 6. We just add 7, 6 with the minus 1, 0. It's a parallel addition here. So 7 plus minus 1 means that is 6, and 6 plus 0, that is also a 6. So second sequence considered as a 6, 6. So we are just considering the next sequence. If we consider the next sequence, that is 3, 4, 5 minus 6. So we are here also adding with the 3 plus 1, that is 4, and 4 plus 6, that is 10. So similar way we just get the value of output, that means the final output. So finally in the last sequence, the y6 sequence, here we y6n sequence, here we consider 5 plus 2, that is 7, 3 plus 3 is a 6, and last one we just we are considering, that is 4 minus 3. So you know the linear convolution, this is on the linear convolution, the total length, that is xn length, add with the hn length minus 1, that is, here we consider the this length is xn length is 12 and hn length is 3, so total length is 14. You just check the final output data sequence also the length of 14. And this is the method of the linear convolution absolutely, but here we apply the circular convolution. So this is one of the circular convolutions application, we can say. So hopefully you understand the both the method, overlap, save and add method. Thank you for listening the video.